All right, guys, so this is part 2 of the final the spring review. So we're going to go ahead and get started on this. So again, feel free to pause, rewind, fast forward, whatever you need help with. You don't have to watch this all. So just help yourself with what you need. Okay, so again, on definitions, we're kind of just going to get the gist of them. So excess reactant. So that is the reactant that's going to have some left over. Okay, so the reactant, helps if I turn my pen on. The reactant that will have some left over. Okay, so remember your reactants are on your left side of the arrow. So basically you usually have 2 of those reactants. So one's going to have left over and one's going to run out completely. The one that's going to run out completely is going to be your limiting reactant. So this is the reactant that is all used up. Okay, so it's one of the ingredients that's used up, and the excess is the one that is going to have leftovers. Okay, mole ratio. This is going to be basically the moles of one substance compared to the moles of another substance. Okay, so what I mean by that is if I have a formula like this, so 2A plus 3B gives me 2AB, something like that. A mole ratio would be like for every 2 moles of A, I have 3 moles of B. Okay, actual yield, this is the amount of product that actually is obtained from the experiment. So once we actually did the experiment, this is what was actually obtained. Theoretical yield is the amount of product produced or obtained on paper using a conversion from the limiting reactant. So from the limiting reactant. So it's the amount of product that's produced on paper from the limiting reactant. So actually is what you get in real life. Theoretical is when you do your conversion on paper. That is like the perfect scenario. Okay, and then percent yield deals with both of those. So percent yield is basically how successful was the actual experiment. So you do your actual amount over your theoretical times 100. Okay, so actual is always going to be the smallest number, the smaller number, because theoretical is the perfect scenario. So if you ever want to know which one to put on top, it's always going to be the small one, because if you get over 100%, that means you did something wrong. Okay, so number 1, sulfuric acid reacts with barium hydroxide by double replacement. If 30 grams of sulfuric acid reacts with 25 grams of barium hydroxide, 1, find the limiting reactant. 2, find the mass of barium sulfate produced. And 3, mass of excess reactant after the reaction is complete. So when we want to find the limiting reactant, we want to know which one's going to run out first, H2SO4 or BaOH2. Okay, so remember, limiting reactant has to be on the left side of the arrow. So that means these 2 right over here cannot be limiting reactants. So what I'm going to do is you could honestly choose whichever 2 to go to if you wanted to. You're still going to find the same correct answer. But I'm going to go ahead and look at number 2 right here. It says find the mass of barium sulfate produced. So I'm going to go ahead and do a conversion to that, so I don't have to do another one. Because if you chose to do H2O, which is fine, you would have to do it again. You'd have to do another conversion to BaSO4. So I'm going to go ahead and just do BaSO4 just to knock it out. So what we're going to do is you're going to start with 30.0 grams of sulfuric acid, so H2SO4. And I'm going to convert that all the way to grams of BaSO4. So my next step would be always bring the units down to the bottom next. So grams of H2SO4 goes on bottom. And that's going to equal 1 mole of H2SO4 on top. Okay, so 1 mole equals the mass of H2SO4. If you look up on the periodic table, it is 98.078. Okay, my next step is I'm in moles of H2SO4 now, so I'm going to bring moles of H2SO4 on bottom next. Okay, and I'm trying to get to barium sulfate, so I'm going to do moles of BaSO4 on top. So I'm going to look at how many moles I have. So let's just make sure everything is balanced. I have 2 hydrogens on the left, 2 hydrogens on the right. Well, technically I have 2 hydrogens on the left and then 2 hydrogens right here on the barium hydroxide. So there'd be 4 on the left and only 2 on the right. So I honestly need to put a 2 in front of this H2O. Not that it's really going to matter. Okay, so that fixes my hydrogens. Oxygens, I have 6 on the right and I have 6 on the left, so there, that one's good. I have 1 sulfur on the left, 1 sulfur on the right, 1 barium on the left, 1 barium on the right, so that means it is balanced. So that means I only have 1 mole of BaSO4, so I'm going to put 1 on top. And I only have 1 mole of H2SO4, so I'm going to put that on bottom. Okay, so I need grams of barium sulfate, so I got to go one more step. So you're going to bring moles of BaSO4 on bottom next, and I know that 1 mole equals the mass of BaSO4 on top. Okay, so you look up that on the periodic table, and I get 233.39 grams. Okay, so that means I'm done, so I'm going to multiply everything on top and then divide by the bottom, and I get 77.7 grams of BaSO4. Okay, so I need to do another conversion. I'm already done with 30 grams of sulfuric acid, so I need to do 25 grams of barium hydroxide next. So I'm going to start off with 25.0 grams of BaOH2. I'm going to do the same thing. I'm going to go 2 grams of BaSO4. So I'm going to bring grams of BaOH2 on bottom. And that's going to equal 1 mole of BaOH2 on top. Okay, and I'm going to look up the mass of that on the periodic table, and I get 171.342. Okay, so I'm out of grams and moles now, so I'm going to bring moles of BaOH2 on bottom next. And I need to get to BaSO4, so I'm going to do moles of BaSO4 on top. I only have 1 mole of BaSO4 and I only have 1 mole of BaOH2. So there's only 1 right here. Okay, so I need to go to grams. So I'm going to bring moles of BaSO4 on bottom. I know that 1 mole equals the mass of BaSO4. And I already have that just above it. That is 233.39 grams. So what I'm going to do is I'm going to multiply all that out, divide by the bottom. That gives me 34.1 grams of BaSO4. So that answers my question 2. That is how many grams of barium sulfate I can produce. Okay, so question 2 is answered. Question 1 is which one's the limiting reactant? Okay, whichever one produces the smallest amount is the limiting reactant. So that means BaOH2 is my limiting reactant, and H2SO4 is my excess reactant. Okay, so whoever produces the smallest one is your limiting reactant. And then this number right here that I solved right here, that is your theoretical yield. So if you ever want to know what theoretical yield is, that is basically the answer you get when you do a conversion. Okay, question number 3 is what is the mass of the excess reactant after the reaction is complete? So I want to know how much H2SO4 is left over. So what I need to do is one more conversion. You're going to start with 25.0 grams of BaOH2. And we're going to go all the way to grams of H2SO4 now. So you're going to go from your limiting reactant to your excess reactant now. Okay, so I'm going to just do the same thing. So grams of BaSO4 goes on, BaOH2 goes on bottom. Okay, we already know the masses. We already found that in the top 2. So that's 171.342 equals 1 mole of BaOH2 on top. Okay, I'm going to bring moles of BaOH2 on bottom. And now I'm trying to get to H2SO4, so you're going to do the moles of H2SO4 on top. This is going to be easy because this is just a 1-to-1. And then lastly, I need to figure out how many grams of H2SO4 we actually used. So I'm going to bring moles of H2SO4 on bottom. I know that 1 mole equals the mass of H2SO4. Okay, and that we already know is 98.078 grams. Okay, so multiply everything on top, divide by the bottom, and I get 14.3 grams. So that is not my answer. That is just how much I actually used. We want to figure out how much is left over. And I dumped in 30 grams of sulfuric acid. So all you have to do is take that 30.0 minus 14.3. That means I'm going to have 15.7 grams of H2SO4 left over or excess. And that is your answer for question number 3. Okay, number 2, a piece of magnesium burns in the presence of oxygen, O2, forming magnesium oxide. How many moles of oxygen are needed to produce 12.5 moles of magnesium oxide? Okay, so basically there's a lot of fluff in these questions. So basically this whole first sentence just told me what was going on. Okay, so you honestly really don't even need it. All I care about is what it's asking for and what it gave me. So it's asking for moles of oxygen. So I'm looking for this. And I was given 12.5 moles of magnesium oxide. Okay, so that was what I was given. So I'm going to start off with what I'm given. So 12.5 moles of magnesium oxide, which is MgO. Okay, and here's one of the big mistakes I see is I instantly see students already want to go into grams. Okay, so if I'm already in moles, there is no need to go into grams. Okay, the whole reason we do the gram shift is to get out of grams and into moles. So since I'm already in moles, don't worry about doing mass. Okay, I'm going to bring moles of MgO on bottom, and I'm trying to get to O2, so this is where you can do your mole to mole jump, so moles of O2. Okay, so there are only 1 mole of O2, and there are 2 moles of MgO. Okay, and then I also see students instantly go into finding grams again. If I ask for grams, that'd be great. You'd be right. But since I asked for moles and I'm already in moles of O2, you need to stop here. So not every one of these has to be 4 steps long. Okay, so these can be simple mole to mole conversions. So multiply 12.5 times 1 divided by 2. And you get 6.25 moles of O2. Okay, calculate the mass of sodium chloride. So I'm looking for mass of sodium chloride. So now I'm looking for grams. And I was given 5.5 moles of sodium. So that's what I was given. Okay, hint, the equation is not balanced. So let's take a look. 1 Na on the left, 1 Na on the right, 2 chlorines on the left, only 1 on the right. So I'm going to put a 2 in front of this NaCl. That fixes my chlorines, but now I need to fix my sodium, so that becomes a 2 right there. So now what I'm going to do is I'm going to start off with 5.50 moles of sodium, which is just Na. And I'm going to go to grams of sodium chloride. So I'm already in moles of Na, so I don't need to know the mass of Na. So I'm going to bring moles of Na on bottom. And now I can go to moles of NaCl. Okay, there are 2 moles of Na and 2 moles of NaCl. So I need grams, so I need to go one more step. So moles of NaCl is on bottom. Well, I know that 1 mole of NaCl equals the mass of NaCl on top. Okay, and the mass of NaCl is 58.44 grams. Okay, multiply everything on top, divide by the bottom, and you should get 321 grams of NaCl. Okay, balance the following equation and determine the mass of copper. So I'm looking for mass of copper. So there's your question mark. And I was given 12.0 grams of silver nitrate. Okay, so I need to balance it first. I have 1 copper on the left, only 1 copper on the right. So those are good. 1 Ag on the left, 1 Ag on the right. Those are good. 1 nitrate on the left, 2 nitrates on the right. So I'm going to need to put a 2 in front of this AgNO3. But now that changes my Ag, so I need 2 on the right, so I'm going to put a 2 in front of this. And now everything is nice and square, so I'm just going to fill in the rest with these 1s just so you can see those. So I'm going to start with 12.0 grams of silver nitrate, so 12.0 grams of AgNO3. Okay, and I'm going to do, this is going to be the long one, so I'm actually in grams now, so I need to get out of grams and into moles. So I'm going to put grams of AgNO3 on bottom. Sorry. I think my pen is actually dying, so I'm gonna charge this, and then it looks like I'm gonna make a part 3 because I really don't want to go back and restart this. So I'm gonna charge this and I'm gonna make a part 3.